Welcome to the DIY Honda Garage channel. In this presentation, we will be focusing on the Diagnostic Trouble Code DTC P2800, which pertains to the transmission range switch ATP reverse switch, also known as the RVS switch, for the Honda Pilot models from 2016 to 2022. This particular error indicates an open or short in the electrical circuit associated with the transmission range switch. It is crucial to understand that this issue is related to the electrical system and not a mechanical fault within the transmission itself. Therefore, our troubleshooting will center on the electrical components involved. The presentation will guide mechanics through the process of verifying the fault and determining the specific area of failure based on detailed diagnostic steps. Let's dive into a detailed error description to better understand the components in question. The transmission range switch, which is crucial in the functionality of the automatic transmission, is located within the transmission assembly. Its main role is to monitor the position of the gear shift lever, providing necessary feedback to the powertrain control module, PCM. This switch ensures that the transmission operates correctly in various gears, including reverse, which is particularly pertinent when diagnosing DTC P2800. In situations involving the reverse gear, the signal from this switch is analyzed by the PCM. If the signal does not match the expected parameters, the PCM will trigger the DTC. This diagnostic code indicates that the electrical circuit related to the ATP RVS switch may be experiencing an open or short, leading to the malfunction. Understanding the function and location of these components is vital for effective troubleshooting. The possible causes for DTC P2800 primarily relate to electrical issues rather than mechanical ones. One of the main causes is a malfunction within the electrical circuit, which could include an open or short circuit configuration. Additionally, the transmission range switch itself could be faulty, meaning it may not correctly relay the shift lever's position to the PCM. Other contributing factors can include poor connections within the wiring harness or loose terminals, which may disrupt the signal being sent from the switch to the PCM. It is essential to check these electrical connections and components during the troubleshooting process, as many of these issues can often manifest as intermittent faults, compounding the diagnosis if not caught immediately. Effectively addressing these areas will be key to resolving the DTC. Drivers may experience several symptoms associated with DTC P2800. Most notably, the illumination of the check engine light on the dashboard. This warning signifies that the vehicle's onboard diagnostic system has detected an issue that needs attention. Other symptoms may include noticeable problems shifting the transmission, particularly when trying to engage reverse. An inability to shift to reverse can severely impact vehicle operation and safety. Additionally, because DTC P2800 may relate to intermittent electrical issues, drivers may observe erratic behavior where the transmission intermittently fails to engage correctly. Understanding these symptoms helps mechanics prioritize their troubleshooting approach, ensuring an efficient diagnosis while addressing the driver's concerns. The first step in the troubleshooting process for DTC P2800 involves problem verification. Begin by turning the vehicle to the on mode without starting the engine. Using the Honda Diagnostic System, HDS, check the parameters related to the reverse switch while the shift lever is in the R position. It is important to monitor the current conditions to determine if they match established thresholds for normal operation. If the current conditions align with the threshold values, the system is deemed to be functioning correctly at that moment. Be aware that if a freeze frame or onboard snapshot of this DTC exists, that data should be employed to replicate the conditions under which the failure was previously observed. This initial step aids in identifying intermittent issues and ensuring all data is collected for further diagnosis. In this second troubleshooting step, begin by turning the vehicle to the off/lock mode to ensure safety during the process. Next, disconnect the transmission range switch 10P connector to isolate the switch from the circuit. To conduct the check, use a jumper wire to connect terminals A and B, where terminal A corresponds to female terminal number 5 of the transmission range switch 10P connector, and terminal B connects to body ground. After making this connection, turn the vehicle back to the on mode. Once in this state, you will again monitor the parameters using the HDS to check if the current condition of the reverse switch returns an on signal. If the current condition matches the threshold, it indicates a fault within the transmission range switch itself, which would require replacing this component. If not, you would then proceed to the next troubleshooting step. The final step in your troubleshooting protocol for DTC P2800 involves conducting an open wire check on the ATP RVS line. Start by turning the vehicle off and removing the previously connected jumper wire. Then, utilize the HDS to jump the SCS line. It is important to wait for more than 1 minute after this action to allow the system to reset. Following this period, disconnect the PCM connector B, which consists of 51 pins. At this point, continuity should be checked between test points 1 and 2 under the following conditions. The vehicle should still be in the off/lock mode, and the connectors related to the transmission range switch and PCM must be disconnected. Test point 1 is the female terminal number 5 of the transmission range switch 10P connector, while test point 2 is pin number 38 of the PCM connector B. If continuity is present, the ATP RVS wire is operating correctly, indicating a potential fault with the PCM, which would necessitate replacement. However, if there is no continuity, this signifies an open circuit in the ATP RVS wire that needs to be repaired between the transmission range switch and the PCM. Once repairs are made for the issues arising from DTC P2800, it's crucial to implement a final verification process. Begin by clearing the Diagnostic Trouble Codes, DTCs, from the vehicle's memory using a diagnostic scanner. This step ensures a clean slate for further diagnostics and testing. After clearing the codes, perform a test drive to assess the vehicle's overall operation, particularly focusing on the transmission's performance while shifting into reverse and other gears. During the test drive, monitor for any reoccurrence of the DTC, paying close attention to any warning lights or unusual behaviors. A successful test drive without any reappearance of the DTC confirms that the repair efforts have resolved the underlying issue. This verification step serves to ensure that both the technician and the customer have confidence in the reliability of the repair. To help prevent the occurrence of DTC P2800 in the future, preventive maintenance should be a top priority. Regular inspections of the vehicle's electrical components can identify early signs of wear or damage, particularly in the wiring connected to the transmission range switch and PCM. Routine checks of these electrical connections for signs of corrosion or looseness are vital, since poor connections often lead to the kinds of faults associated with this DTC. Another important aspect of preventive maintenance is ensuring that the transmission fluid levels are adequate and that the fluid is free from contamination. Proper fluid maintenance supports the overall health of the transmission system, reducing the risk of future errors. By implementing these preventive measures, you can help extend the lifespan of crucial components and minimize unexpected breakdowns. In summary, the troubleshooting process for DTC P2800 is critical in resolving electrical issues related to the transmission range switch, ATP reverse switch. Throughout our presentation, we identified the electrical nature of the problem, emphasizing that these issues stem from the circuit rather than mechanical faults. The focus should be on evaluating the condition of the transmission range switch, the connections leading to the powertrain control module, and conducting thorough diagnostic steps while interpreting data accurately. After resolving the DTC, implementing preventive maintenance practices will further ensure the reliability of the vehicle's systems. Through careful adherence to detailed troubleshooting steps and verification methods, technicians can effectively address DTC P2800 and enhance the performance of the Honda Pilot. Please like and subscribe to the channel. See you next time.